think I'm going to change one of my examples. Okay, so we're going to talk about inverses. This is something we did a little bit in Algebra 2, but you might want to pay attention because I don't think we went to like all the way to verifying. There's going to be two things we do today. We find inverses and we're going to verify inverses. Finding inverses is super easy. The definition of an inverse function is one that if I have a graph that looks like this, its inverse looks like this. So basically all of the x's and y's are switched. So if I have the point 0, 1 on one graph, its inverse is going to have the point 1, 0. Okay, so you just basically, you're switching the x's and the y's if you're looking at the graphs of them. We're not going to do a lot with graphs, but when we're finding inverses, the first step is to switch the x and the y. So I just wanted to show you why that is. So if I give you something like this, f of x equals 4x, and this is going to be finding an inverse. Step 0, so it's really not a math step to find it, but step 0 is I want you to change the f of x. What is f of x? It's just a fancy y. So I'm going to make it a y equals 4x. If it gives it to you as f of x or g of x, I want you to first change it to y because it'll match up with my steps. Your first step is to switch the x and the y. If it's an x and an f of x, then you might be confused. So first step is switch x and y. Don't do any math. Just switch their places. So in this case, it would be x equals 4y. So I didn't do any math. I just changed their places. Like if Naomi and I are going to change places, I'm going to sit down, she's going to stand up. Nothing changed except for our places. So no math done, just switch the x and y. And then the second step to solve for an inverse or to find an inverse is to solve for y. So we're going to get y by itself. How do I move that 4 that's in front of y? Divide. So we're going to divide by 4, divide by 4. So I end up with y equals x over 4. And this is the inverse. Let's see if your book uses this notation. Oh, it does. So if I wanted to change this back to f of x, like it started out as, to show that it's an inverse, you use this little -1. You do f -1 of x equals x over 4. This is just a fancy y that says the inverse of f. Doesn't mean, I'm not going to count you wrong if you don't write this, but if you see this, just know that this is just a fancy y that means that wherever the f function is, this is its inverse. How was that? 2 steps. Switch x and y, solve for y. Let me give you another one before we go on to verifying.
Wait, so that's just a fancy way of saying that's the inverse?
Mm-hmm. It's just a notation. Let me give you another one, then we're going to go on to verifying, which I'm already changing my mind which one I want to verify. We might only have 3 examples. So let's do one that's a little more involved. So we're still finding the inverse. I'm going to give you f of x equals 5 minus 3x all divided by 2. What's our step 0? Okay, so I'm going to rewrite this as y equals 5 minus 3x over 2. And then step 1, switch x and y. So don't do any math, just switch the x and the y. So now I've got x equals 5 minus 3y all divided by 2. And then step 2, solve for y. So to solve for y, I need to get this 2 off the bottom. What am I going to do with the 2? Okay, multiply by the reciprocal, or just cross multiply it up. So I have 2x equals 5 minus 3y, and you guys finish this problem. I'm going to subtract my 5 over. So I have 2x minus 5 equals negative 3y. Then I'm going to divide by my negative 3. So I have y is equal to 2x minus 5, all divided by negative 3. You can go ahead and split that up if you want, or you can leave it like this. Did you guys leave it like this? Okay. So I could write it as y equals that, or I could get fancy and say f inverse of x equals 2x minus 5, all divided by negative 3. Because we're pretty fancy in here. Okay, so that is finding the inverse. That's half of our lesson today. How do you guys feel about that? Good? Switch x and y, solve for y. Okay, the second part of our lesson today is verifying. And this is where we have to use our lesson from yesterday. So if I want to verify, for verifying means I'm going to make sure that they're inverses. I'm going to give you two equations. And you're going to have to compose them, f of g of x, and if it equals x, and then flip it around and go the other way, like you guys did on your homework yesterday. G of f of x, if that equals x, if both of these equal x, then they are inverses of each other. So if I give you, well, maybe I'll give you the one that works here. Oh, that is just a... Well, let's do it. Okay, if I give you this, f of x is equal to 5 over x minus 2. And then I'm going to tell you that g of x equals 5 over x and then plus 2, like this. Okay, I need to compose this by going f of g of x first. If that equals x, if it simplifies down to x, then I'm going to do the other way. And if that simplifies down to x, then I know that they're inverses of each other. So yesterday I told you to work from the inside out. So what am I going to replace this g of x with?
5 over x.
Okay, 5 over x plus 2. So I have f of 5 over x plus 2. That's my input. Now I'm going to take this input and I'm going to go into the f function and plug it in for that x right here. This is going to look crappy, but it's going to work out okay. So it's going to be 5 over this part right here. It's going in for this x. So I have 5 over x plus 2. And then I have got on the bottom minus 2. So this was the x that I put this input in. Okay? On the bottom, what happens with the 2 and the negative 2?
Cancel.
Okay, they're going to simplify out, leaving me with 5 over x. What do you do when you are dividing by a fraction? You multiply by its reciprocal. What's the reciprocal of 5 over x? X over 5. So I'm going to take this and multiply it by x over 5. Those 5 simplify, so I'm left with x, which is what I want it to be left as. So now we're going to try to go the other way, because this one, if this one would have been like 2x or x plus 1, then we're done. They're not inverses. But because one of them was x, now I have to show the g of f of x. You guys want to try this one on your own?
No.
Okay.
Yeah.
Okay, I'll do this one with you. I'll give you the next one to try on your own. So we're going to change from the inside out. So what am I going to replace this underlined part with? Minus 2. So I have g of 5 over x minus 2. So now this is my input for this x right here. So I have 5 over my input, 5 over x minus 2, and then I've got a plus 2, because this is a plus 2 here. Let's fix this fraction within a fraction here. I need to multiply by this reciprocal. and the reciprocal of 5 over x minus 2 is x minus 2 over 5. What's going to happen with my two 5's here? Okay, that leaves me with x minus 2 plus 2, which is just
X.
So I can say that f of x and g of x are inverses of each other because of this work. So when you show this on your test, you're not going to just show me equals x equals x. I'm not looking for that. I'm looking for your work, the composition. And this is all the stuff we did yesterday. Okay? Oh dear. Okay, let's do one last one, and then I'll let you guys work. I feel like this is, you know how a lot of times in math I get done with my lesson and then all the problems are harder than the examples? I feel like today's reversed. I feel like I'm giving you the harder examples and your work's actually going to be easier. But there's going to be some of these fraction within a fraction. That's why I wanted to show you. But I think they're going to be easier than this. Okay, so let's do one more thing. I'm going to give you a function. F of x equals the cubed root of x plus 1. We're going to find the inverse, and then we're going to verify the inverses. So we're going to do both in this. We're going to know that they're inverses because we're going to actually find it, but then we're going to try the f of g of x and the g of f of x. So first thing I need to do is make this a y. Okay, before we even start this, how do you undo a cubed root? Cube it. Not cubed root it. Don't cubed root a cubed root. Cube it. So just cube. I heard lots of different things. Okay, first step, step 1. Switch x and y. So I have x is equal to the cubed root of y plus 1. I didn't do any math there. I just switched their places.
Cube both sides.
Now I need to cube both sides because what am I trying to get to?
The problem inside of the...
I need to get to this y here. So I need to get to this problem inside here. So I'm going to cube both sides. And that's going to leave me with an x cubed on the left and just y plus 1 on the right. And then last step,
Oh, wait, no,
subtract the 1. So I've got y is equal to x cubed minus 1. This is my inverse, which I'm going to call this g of x. So I can do the f of g of x and the g of f of x. I'm just going to call it g of x just so I can keep it uniform with the rest of our notes. So now I'm going to tell you, and this might actually be that same problem that you guys had in your homework yesterday. Now I want you to verify. So to verify this, I'm going to use f of x. I'm just going to write this over here because I'm going to move this screen over. F of x is the cubed root of x plus 1, and g of x is x cubed minus 1. I want you guys on your own to verify by finding f of g of x, and then if that works out, which it's going to, g of f of x. So we all know what the answer should be. The answer should be x when we're done. You guys try this and see if you get that. And then I'll give you your little bit of homework, or classwork. It's not homework, it's classwork. Okay, so for f of g of x, I replaced with my g of x, which was x cubed minus 1. I plugged that into this x right here. So I had x cubed minus 1 and then a plus 1. The 1 simplify out, so I have the cubed root of x cubed, which is just x. And then we have g of f of x. So I'm going to take f of x and I'm going to put it into this x right here. So I'm going to have the cubed root of x plus 1 quantity cubed minus 1. The cubed root and the cube are going to simplify out. So I have x plus 1 minus 1, which is just x. And that's your answer. Not too bad?
Not too bad.
No. All this stuff was yesterday. I mean, the only new stuff you learned really was how to find the inverse. So that's good. Okay, here's what I'd like for today. I'm going to put the ball in your court, but I want this done in class today because we're not going to take the time. Well, at the end of class, we'll go over 5 through 12 that I'm going to give you, which is finding the inverse and answer questions. But the second half of your homework is just verifying. So you just need to do that. I just checked. All of them should work out. So you should be able to. So it's just practice being able to do verifying. So I want you to use my answers today as you go through and just make sure you're doing it right. Because tomorrow we're going to spend class time on the concept quiz. We're not going to spend time on this. So when you leave here today, you have to know that you're okay with this stuff. Does everybody understand? Mm-hmm. Okay, that's by checking in my book. And I want this done in class so that tomorrow we can just, since it's a short class, I only want you doing the concept quiz, so then Thursday we can just review. Because this chapter has so many things. Okay. 5 through 20. 5 through 12, you're finding the inverse. Here, I just want you to find inverse. And then 13 to 20, you're verifying. Okay? Because and don't worry about verifying graphically, only algebraically. So, let's just recap. Oh, it's 43. It's all on 43. I don't know why I wrote 44.
Thank you.
Okay, one more time. By the end of class, you know if you know this stuff or not. Because tomorrow we're not spending time going over this. Okay, you guys have 30 minutes. You should be over 30 minutes. You should have plenty of time.